Hi, this is Jayant Abula from IIT Delhi, currently in my fourth year of bachelor's in applied mechanics. Okay, now I'm going to discuss about oscillations of a fluid in a tube. Okay, so let me draw a tube. So this is a tube. Okay, now if you fill the liquid on both at the right end and the left end, the height will be same, right? This we know, and there is gravity. Okay, now what happens if you disturb the liquid at left hand? Okay, we'll try to push down the liquid at the left hand. Okay, so let us assume that we push the liquid by x downward. Okay, so by conservation of mass, the liquid at the right end will go up by x. Okay, this will be x and this will be x. And by logic, we can say if we leave the liquid here, it will oscillate. Right? Now, how can we prove that this is an oscillatory motion and an SHM motion? And how can we find out the time period? Okay, so let us do that. So assumptions. First, we'll discuss about assumptions. Assumption are we will neglect any viscous effects. That means we are going to neglect heat loss and surface tension effects. Okay, this is our assumption. Okay, so now we can say that the total energy, which is the kinetic energy plus the potential energy due to gravity, is equals to a constant because there is no heat loss and the glass doesn't do any work. I mean, the glass applies the normal force on the liquid, but it doesn't do any work. Also, there is an atmosphere force acting at both the ends, but whatever the work done at the left end is equals to negative of work done at the right end. So the net work done by atmosphere is zero. So there is no work done on liquid, right? So we can say the kinetic energy and the potential energy is constant. Okay, so we can say dE by dt will be zero. Okay, and also we will assume that this horizontal portion is negligible compared to the vertical portion. Okay, let us assume the height of the vertical portion as h. Okay, so now we'll write what is Ke. Okay, so the whole fluid will move with the same speed, right? So this is the kinetic energy. And what's the potential energy? Okay, so this is h minus x now, and this is h plus x, right? So the potential energy will be, what's the mass at the left hand? Rho into area into the height into g. Let us assume that this is the zero potential. Okay, so where is the center of mass at? H minus x by 2, right? So we'll multiply by h minus x by 2 plus potential energy of the liquid on right hand. That will be the mass, the gravity into height. Okay, so yeah, go to the next page. So PE equals to rho into A into H plus x whole square by 2 G plus rho into A into H square, sorry, H minus x whole square into G by, so that you will get rho A G by 2 into h square plus x square into b. So that will be rho a g of h square. So what is the total energy? Rho a g h square plus x square plus half into what's the mass? Rho into 2h into a into v square. Okay. So dE by dt is 0. So you will get 2x into x dot into g plus 2v into v dot into h is 0. So that will gives rise to acceleration equals to minus g by h into x. So this is an SHM, right? This equation represents a simple harmonic motion. Okay. So omega square equals to g by h. So what is the time period? 2 pi root over h by g. So it's proven. Okay. So we can also do this by force method, but because of limited time, we are not discussing it. And also, the extension of this question would be a YouTube with slant limbs. This YouTube we discussed as vertical limbs, right? So that will be a good question for JI to ask. Okay. So thank you for giving me this opportunity.